Hi, welcome back to the Chemical Reactions Unit in Science 1206. I'm Miss Ledwell, and in this video, we'll be talking about the properties of molecular compounds. Let's begin. Recall that two categories that chemists use for classifying compounds are ionic and molecular, also known as covalent. Molecular or covalent compounds only contain nonmetals. A binary molecular compound contains two different nonmetal elements. The diagram shows an example of a binary molecular compound. One nonmetal is red in color, and the second nonmetal is blue. Some examples of binary molecular compounds include carbon dioxide, CO2, made up the elements carbon and oxygen, water, H2O, made up the two nonmetals hydrogen and oxygen, and disulfur dichloride, S2-L2, made up of the two nonmetal elements sulfur and chlorine. Remember that nonmetals are located to the right of the staircase on the periodic table of elements, except for the nonmetal hydrogen, which is located on the right-hand side. This image represents carbon, oxygen, and bromine, which are some examples of nonmetals. Recall that when ionic compounds form, a transfer of electrons takes place. An atom of one element loses electrons, and an atom of another element gains those electrons. We talked about that in the last video. On the other hand, molecular compounds are compounds formed of atoms of two or more elements that share electrons to form molecules. For example, nitrogen trihydride shares electrons with the hydrogen atoms. Hydrogen chloride, the hydrogen and chlorine atoms share electrons. In carbon dioxide, the carbon and oxygen atoms share electrons. A molecule is formed when two or more nonmetal atoms are joined by covalent bonds. The covalent bonds that hold atoms together in molecules are very strong. Next, let's talk about covalent bonds and valence electrons. Covalent bonds occur when atoms share valence electrons, which are located in the outermost energy level or shell of an atom. Sharing electrons allows atoms to achieve a more stable electron configuration by filling their outer energy levels, or valence shells. Let's look at phosphorus. How many valence electrons does phosphorus have? If you said 5, you're right. The valence electrons are found in the outermost shell called the valence shell. Now let's take a look at fluorine. How many valence electrons does fluorine have? If you said 7, you're correct. The valence electrons are found in the valence shell or outermost energy level. Phosphorus will react with fluorine to form phosphorus trifluoride, or PF3. When this happens, phosphorus and fluorine will share valence electrons to achieve a more stable electron configuration. Now let's look at some properties of molecular compounds. Molecular compounds exhibit a wide range of properties. They tend to boil and melt at relatively low temperatures when we compare them to ionic compounds. Unlike ionic compounds, molecular compounds do not conduct electricity. When dissolved in water, they remain as neutral molecules. Molecules do not allow the movement of electrons, and therefore they do not conduct electricity, with the exception of molecular acids. Molecular compounds exist in various physical states at room temperature. They may be solids like table sugar, C12H22O11, liquids like water, H2O, or gases such as carbon dioxide, CO2. Since all ionic compounds are solids, any pure liquid or gas compound can be classified as molecular. To differentiate between solid compounds, one reliable test involves examining electrical conductivity. Ionic compounds, when dissolved in water, break up into their ions, forming electrical conductive solutions. In contrast, molecular compounds dissolved in water do not conduct electricity. Let's do a side-by-side comparison of the properties of ionic and molecular compounds. First, let's look at the composition. Ionic compounds are composed of ions. Binary ionic compounds consists of two elements, a metal and a nonmetal. Binary molecular compounds, on the other hand, are composed of two nonmetals. What about the state at room temperature? Ionic compounds are all solids at room temperature, while molecular compounds can be solids, liquids, or gases. For the melting point, remember that ionic compounds have relatively high melting points, generally above 300 degrees Celsius. Molecular compounds tend to melt at relatively low temperatures when we compare them to ionic compounds, generally lower than 300 degrees Celsius. For electrical conductivity, ionic compounds have very good electrical conductivity when dissolved in water or in the molten or liquid state. Molecular compounds are poor electrical conductors or are non-conductive. For bonding, ionic bonds form due to the transfer of valence electrons, while with molecular compounds, covalent bonds form due to the sharing of valence electrons. Some examples of ionic compounds are sodium chloride, NaCl, and calcium phosphide, Ca3P2. For molecular compounds, some examples are water, H2O, sugar, C12H22O11, and carbon dioxide, CO2. All three states are represented here in our examples. Water is a liquid at room temperature, sugar is a solid at room temperature, and carbon dioxide is a gas at room temperature. Now it's time to review. Complete the learning activities you'll find in Brightspace.